Hello, Wharton students. Today, we're going to solve some practice problems on bias and variance trade-off from NYU assignment. So the question is, let xy equals fx plus epsilon be measured relationship and y hat equals gx be the model predictive value of y. Then MSE over the test instance, xi is given by this MSE formula, which is typical MSE formula that we've been seeing. And notice that the expected value of MSE is bias squared plus variance plus noise, the epsilon value. So the first 1.1, the question asks to consider the case when fx equals x plus sine 1.5x and y, and given y with random noise from 0, which has mean 0 and the variance 0.3, where this is a normal distribution with mean 0 and standard deviation of 0.3. And we have to create a data size of size 20 points by randomly generating samples from y with limiting range from x to lie between 0 and 5. So this is a condition. Display the data set and fx in one plot. So we have to plot a scatter plot for y and a smooth line plot for fx. So let's move on to coding question. So before we do the first question, I've already imported some modules that we're going to use, NumPy. So let's first define our given function, which is fx earn x plus NumPy. Last we use NumPy for generating sine plots. Multiplied by x. And then we're going to create a random variable, x, which we can create x equals NumPy. We use linspace from 0 to 5, and we're going to generate 20 numbers. And let's create noise. Noise, we can define as NumPy random. We're going to define random noise, normal, from normally distributed random noise, from 0 to 0.3, and also 20 noises. And let's define y values. I'll say y values here. This is fx plus noise, that noise that we just generated, the normal, that follows normal distribution. And let's plot this using scatter plot, x values, y values. And I'm going to label that as y equals f plus fx plus, and I'm going to label that as yx equals fx plus noise. Great. Oh, here I did x here. So x. All right. So let's I'm going to do this for smooth line for fx. So I'm going to create smooth line for fx. This is y line. This equals NumPy dot linspace from 0 to 5, 200 numbers. And we are going to plot this. I'm going to call this x line. And f of this is f that we just generated. We're going to put fx line here into the function that we generated here. And then we're going to label that as fx equals x plus sine 1.5x. And I'll use color red. Okay. Oops. All right. And then let's plot it. Plot x label. I'm going to label as x. Also label y as y. I'm going to make the title the function plot. Okay. Now I'm going to add grid too. And then finally, blt.show. So let's see what happens. Okay, so we just generated this plot, the polynomial plot with the scatter plots. And the next question is, use the weighted sum of polynomials as an estimator function for fx. In particular, let the form of the estimator function be this. This is a polynomial, nth polynomial degree. Consider 4 candidate estimators, G1, G3, G5, G10. So we're considering 4 cases first degree polynomial, third degree polynomial, fifth degree, and 10th degree polynomial. Estimate the coefficients of each of the 4 estimators using the sample data set and plot yx, yf, g1, g3, g10, the same plot. So we have to figure out which estimator is underfitting and which one is overfitting. So we first have to define polynomial. So we have to import the module called polynomial. So let's first calculate the weighted sum of polynomials. So I'm going to make a function that can fit the polynomial that we desire. So it takes x and y and degree. And let's define coefficients first. The coefficient is the made from the polynomial function, polynomial module that fit x and y and degree. And we're going to convert it as coefficients. And we're going to return MP, as we're going to return it as an array, MP dot poly, first degree polynomial, 1 degree array with coefficients with the last one, with the last coefficients. Okay, so let's define some estimators, the functions, estimators. Okay, oh, so fit. Okay, so this is G1 equals fit polynomial x and y values in first degree. And as the question asked, we have to create 4 of them, which are third degree, fifth degree, and 10th degree. So I'm going to change this accordingly. Now let's plot this scatter plot. So x, y values, and I'm going to label this as yx equals fx plus noise. So I could just do this one as plus noise. And then I'm going to plot this. We're going to put x, instead of x, we're going to input the x line that we defined, this linear space, and p-lin space, the array. So we're going to use line and g1 of x line. I'm going to label it as g1x. So I'm going to do it 4 times with different degrees. Now we can plot this and plt.x label as x and y label as y. And plt.title, I'm going to make a title of polynomial estimators. And put grid was true. And I'm going to show this. And so let's see how it turns out. Okay. All right, looks good. But I think we need some legend here. So pick a legend. All right, so it looks good. So the blue line is the first degree polynomial that we randomly generated. And so the blue line is the first degree polynomial we generated with noise. And the red line is the 10th degree polynomial with noise. Thanks for watching this video. And if you liked this video, please like and subscribe. And if you have any questions, please leave them in the chat.